Effects of heat. Conventional ovens are sources of convection heat energy, causing the food placed into it to become hot. Geothermal energy is a type of heat energy generated and stored beneath the surface of the earth. Geothermal energy is used to heat homes, greenhouses, drying vegetables, drying wood, and dyeing wool, to extracting gold and silver from ore. A huge amount of heat energy is stored in a bolt of lightning, which can strike and start a fire or cause an electrical interruption when any device is in use or functioning. Now, does it matter how much water is being mixed? Yes, it matters. Consider the example such as adding a cup of ice water to the water in a swimming pool. The temperature of the combined water will be lower than the hot water and higher than the cold water. You would have come across many effects of heat on matter. On heating, snow melts while water boils and gradually disappears. When an object is heated, many changes take place. The simplest change is the rise in the temperature of the body. Some changes may not be that obvious. The object may slightly expand in size on heating. A substance may change its state from a solid to a liquid or from a liquid to a gas on heating. This is the most familiar effect of heat. Heat speeds up most of the chemical reactions. Heat can even kill organisms. We boil milk and water in order to kill harmful bacteria present in them. Expansion. Most solids, liquids, and gases expand when heated. Solid upon heat melts into liquid, which upon heat vaporizes into gas. Different substances expand by different amount when they are heated. Metal lids on glass jars can often be loosened by heating them with hot water. Let us perform some activities to study this properly. Activity 1. Take two similar blocks of wood. Place a metal, that is an iron or tin, rod or strip on them as shown in the figure. Fix an end of it firmly on one side. Take a needle and place it under the other end of the rod. Ensure that the rod rests on the needle and does not touch the wooden block. Make a pointer and stick it to the pointed end of the needle. Heat the rod using a spirit lamp. Observe what happens to the pointer. Upon heating, the rod or strip expands and the pointer moves. You will see that the pointer rotates. On heating, the rod expands and the needle below it rolls. Consequently, the pointer attached to the needle rotates. Activity 2. To do this activity, you need a ring and ball apparatus as shown in the figure. When you put the ball on the ring, it slips through the ring. Now, heat the ball for some time and put it on the ring. Does the ball pass through the ring? You will see that the ball does not pass through the ring as the ball has expanded due to heating. Before heating, the ball slips through the ring. Upon heating, the ball expands in size and does not pass through the ring. From the above activities, we conclude that solids expand on heating. On a hot summer day, telephone wires sag between the poles that hold them up. Yet, on a cold day, the wires are tightly stretched. The reason is that most substances expand as they get hotter and contract or shrink as they cool down. Metals, when heated, expand more than other kinds of solids do. Because of this, engineers have to be especially careful when designing and building large metal structures. For example, narrow gaps must be left between railroad tracks at regular intervals. This prevents the tracks from buckling during hot weather. Do liquids and gases also expand on heating? Let us find out.
Let us take a metal ball and ring. The ball can just pass through the ring at normal temperature. Now we shall heat the ball for a few minutes and then try to pass it through the ring. What happens? It gets stuck. This means that the ball has become slightly bigger on heating, that is, it has expanded. This expansion or increase in the size of a body when it is heated is called thermal expansion.
Take a test tube and a rubber stopper with a hole in it. Insert a hollow glass tube in this hole so that it fits tightly in the rubber stopper. Fill the test tube to the brim with water. Fix the stopper to the test tube so that a small amount of water rises in the tube as shown. Mark the level of the water in the tube. Now heat the test tube over a flame and observe the level of water in the tube. You will see that the level of water rises in the tube. To observe this effect more clearly, you can color the water. Stop heating the test tube and let it cool down. Observe what happens to the level of water.
Thermal expansion. It is our common experience that when the stopper of a bottle is stuck, we heat the mouth of the bottle. The mouth expands on heating and the stopper comes out easily.
The expansion of substances on heating has many uses in our daily life. The metal cover on glass jars can be loosened by running hot water over the metal lid. The metal lid expands due to heat and loosens its hold on the glass bottle. Similarly, when an iron rim is to be fitted on a wooden wheel of a bullock cart, the ironsmith always heats the rim first. This expands the rim so that it slips easily on the wheel. As the rim cools, it contracts to the original size and fits tightly on the wheel. Steel bridges have to allow for the expansion. Concrete also expands when heated. Concrete bridges are built with expansion joints needed to keep the bridge from buckling when the concrete expands on hot summer days. For the same reason, little gaps are left between the sections of a railway track. Now give reason for the following. When you touch a cold surface, does energy travel from the surface to your hand, or does energy travel from your hand to the cold surface? Also, give reason for your answer. Heat always travels from hot to cold. Heat will leave from our body and try to heat up the cold surface, so the energy will travel from the surface of our hand to the cold surface. Which of the two, a solid or a liquid, generally expands more on increase in temperature? Liquid expands more with the increasing temperature. The reason that solids expand less than liquids is due to the spacious difference between the particles of a liquid and a solid. Now, why does a glass tumbler sometimes crack when hot water is suddenly poured into it? Glass tumbler break due to the difference in thermal expansion of the inner and outer surfaces. Glass is known as a bad conductor of heat. Hence, when the tumbler is suddenly filled with hot water, the inner layer of the glass gets heated immediately as it comes into contact with the hot liquid. But the outer layer remains at a lower temperature for some more time as the heat is conducted through the glass only slowly. As a result, the inner layer tends to expand more than the outer layer. This leads to cracking. Have you noticed a gap left between two pieces of rails in the railway line? What are these gaps meant for? Narrow gaps must be left between railroad tracks at regular intervals. This prevents the tracks from buckling during hot weather.